So today we are diving into the difference between a self-determined and a context-determined expression. So if you have ever struggled with unexpected bitwidth or mysterious behavior in your system Verilog code, this video is for you. So let's break it down with some examples. First, let's talk about a self-determined expression. So in this type of expression, the width of the result is determined solely by the operands themselves. So no external context affects their size. So let's write an example code to understand this. So right here we have two logic values. One is of 8 bits and the other one is of 4 bit. I will assign some value to the variable a. Then I will assign the concatenation of a with itself to the y. I will also use a dollar display and I will display the value of y. I will run the simulation using my run.to. Okay, so I want the value to be in binary. So I will change the D to B and I will run it again. So here you can see the value of y is 8 times 1. So here in this case, each a is of 4 bits. So the total width is 4 plus 4, 8 bits. So in this particular case, the width is determined internally by the operand. System Verilog doesn't extend or truncate anything. It's self-contained. Because here y is of 8 bits and also the concatenation of a with itself is of 8 bits. Uh, Both the width of LHS and RHS matches perfectly. So System Verilog directly assign this value without any sorts of adjustment. So the question is now, what are context determined expressions and how do they differ from the self-determined expression? So in context determined expressions, the width depends on the entire expression's context, like the length of all the operands. Let's modify the code to make it context determined. And we can do this just by adding one here, right here. So let's run the simulation again. And before that, I want to add another dollar display. And I will print the value of A in binary. Let's run it. So here we can observe that the value of A is equals to 4 times 0 and the Y is 8 times 0. So what's the reason behind this? Let's understand this. Now just this one, it makes the entire expression to be context determined. It is because this one is of 32 bit and this value is of 4 bit. So what happens here? After the addition of these two, we get a 32-bit value. It will be something like this: 32-bit, 0, till it gets to 1, 4 times 0. So this is the final expression which we receive after the addition of this. But during the assignment, as you can see, 1 is of 4 bits. So the entire value will be truncated to get assigned to A. So what will be the last 4 LSB of this expression? These are 0, 0, 0, 0. So the final answer of A will be 0, 0, 0, 0. So after receiving this answer, we are concatenating A with A and assigning it to Y. So that's why we are receiving 8 times 0. So just the addition of this one makes the entire expression to be context determined. It extends the value to be 32-bit, and after the addition, because of the 4 bits limitation of A, it gets truncated. Still, to understand the difference between them in a better way, let's write a different example. I will be erasing this and I will be writing two if else conditions. So here we can see in the first condition, I have a 1-bit value 1 and it will be shifted to the left side for 15 times. Then after this, it will be shifted to the right side for the 15 times. And then it is conditioned to be 0 or false. If that the condition is true, then it will display true, else it will display false. Similarly, in the other if else condition, you can see it is again being shifted left for 15 times, then shifted to the right for 15 times, but here it is ORed with a 20-bit value of zeros. After that, let me correct it, it should be equals to, after that it is equated to 0, a 1-bit value. And if the condition is true, it will display true, else it will display false. So let's run this code. Okay, I forgot to save the file. Let's do it again. Okay, we made a mistake here. Let me delete one of the bracket. Let's save it and run it again. Okay, so what is happening here? So let's go through it. So the first condition is printing true and the second condition is printing false. So why is that? So let's begin with this one. So here you can see we are shifting a 1-bit value 1 15 times to the left. So what will happen if we do that? So let's try understanding. So here we have a 1-bit value 1, and if we shift it even by 1 time, so what will happen? We will get this. It is because it's a 1-bit value, and when we shift it left, the 1 falls off the left edge, leaving it like this. And what happened next, that we shift it by right side for 15 times, it doesn't change because we are shifting 0 by 15 times. So we will still get 0, a 1-bit value. And when we equate it to this 1-bit value, which is also 0, so the condition passes and we get true. So this condition will always be true because of this. So here again, the 1-bit 1 is of 1 bit and it is context determined, but here the context is itself of 1 bit. So the extension doesn't happen in this case. So now let's move with our other case. And in this particular case, we can see that we are shifting the same 1-bit 1 value left by 15 times. But here's the catch. As you can see, we are ORing the value with a 20-bit 0, which changed the context. So this particular operand will get equal number of bits equals to the largest operand. So the operand that has highest number of bits. So what are the highest number of bits here? 20 bits. So it will be extended to 20-bit value. It will be like this. And 0 0 0s until it get 0 1. So here if we will do the shift by 15, it will indeed get a shift to some value. One will be shifted to somewhere here, and after this it will get shifted back to its original position because of this right shift by 15. And after that it will be ORed, and here the major role of the OR is to do the bit extension and make this context determined. So after that, if we equate the value to 0, the condition fails because we receive 1 at the end after we do both the shift. So that's why this particular expression will always display false. So this was the difference between self-determined and context-determined expressions. Thank you so much.